Imagine for a moment that you could close your eyes in the vast emptiness of space and sleep for 1 million years. Picture yourself drifting in the cosmic dark, suspended between stars, while time flows around you like a gentle river. What would you find when you finally opened your eyes again? What changes would have unfolded in the universe while you rested in the infinite quiet? This is, of course, a purely hypothetical journey. The human body, as remarkable as it is, cannot survive even minutes in the vacuum of space without protection, let alone 1 million years. But tonight, we're going to explore this impossible dream together, using the gentle lens of science to imagine what such an extraordinary sleep might reveal about the nature of time, change, and the cosmos itself. Let's begin by understanding what would need to happen for such a journey to even be conceivable. In reality, the moment a human body is exposed to the vacuum of space, a cascade of biological processes would begin that would end life within minutes. The absence of atmospheric pressure would cause the water in your blood and tissues to boil at body temperature. Your lungs would rupture if you tried to hold your breath. The extreme cold of space, hovering around negative 270 degrees Celsius, would begin freezing your body almost immediately. And then there's the radiation, cosmic rays and solar particles that would damage your cells beyond repair. So for our thought experiment to work, we must imagine that some extraordinary technology of the far future has solved these problems. Perhaps a form of cryogenic preservation so advanced that it could maintain your body in perfect stasis for geological timescales. Maybe a protective field that could shield you from radiation while keeping your biological processes suspended in time. This technology doesn't exist today and may never exist, but let's imagine it could and see what such a long sleep might teach us about the universe. As you drift into this million-year slumber, your body would need to be maintained in a state that defies everything we currently understand about biology and physics. Your cells would need to stop aging, your brain would need to cease its constant electrical activity, and yet somehow the essential spark of consciousness would need to be preserved, waiting patiently for the moment of awakening. It's a beautiful impossibility, but one that allows us to explore something profound about the nature of time itself. While you sleep, suspended in the cosmic void, the universe would continue its ancient dance of motion and change. And the first thing you might notice, if you could somehow observe while sleeping, is that space itself is not the empty, static void it might appear to be. It's alive with movement, filled with invisible forces and energies that shape everything we see. The very space around you would be slowly expanding. This expansion, driven by the mysterious force we call dark energy, occurs at a rate so gentle that cosmic distances increase by only 0.007% in 1 million years. It's an expansion so subtle that if you were sleeping next to a distant galaxy, you would drift away from it by the tiniest of margins, like two boats slowly separating on a vast calm ocean. But space is not empty. Even in the deepest void between galaxies, there are particles drifting by, remnants of ancient stellar explosions, wisps of hydrogen gas, and the invisible presence of dark matter. As you sleep, these particles would occasionally interact with whatever protective field surrounds you, creating the faintest of glows, like cosmic fireflies dancing in the dark. The radiation environment around you would tell its own story of cosmic time. High-energy particles from distant supernovae, some of which exploded millions of years before you began your sleep, would continue their journey across the galaxy. The cosmic microwave background radiation, the afterglow of the Big Bang itself, would grow slightly cooler and more redshifted as the universe continues to expand around you. These changes would be so subtle that only the most sensitive instruments could detect them, but they represent the universe's slow march through deep time. As your million-year sleep progresses, the most dramatic changes would begin to unfold in the stellar neighborhood around you. Stars, those brilliant nuclear furnaces that light up the cosmic dark, live their lives on timescales that make our human experience seem like a brief flicker. But even in the span of 1 million years, which is just a moment in cosmic terms, some stars would complete their entire life cycles while you rest. The most massive stars in the galaxy, those brilliant blue giants that burn with the intensity of millions of suns, have lifetimes measured in mere millions of years. Any O-type star you might have observed before your sleep, those stellar giants 40 times more massive than our Sun, would have already died during your slumber. These stellar titans would have exhausted their nuclear fuel, swelled into red supergiants, and then exploded in catastrophic supernovae that briefly outshone entire galaxies. The deaths of these massive stars would have left behind exotic remnants. Some would have collapsed into neutron stars, objects so dense that a teaspoon of their material would weigh as much as a mountain. Others, the most massive of all, would have collapsed beyond even neutron degeneracy, creating black holes whose gravitational pull is so strong that not even light can escape their embrace. These stellar explosions would have enriched the space around you with heavy elements forged in the nuclear furnaces of dying stars. Iron, carbon, oxygen, and dozens of other elements would have been scattered into the cosmic winds, mixing with the primordial hydrogen and helium that fills the space between stars. This enriched material would slowly coalesce under gravity's patient pull, forming new clouds of gas and dust that would eventually give birth to new generations of stars and planets. The stellar landscape you would awaken to would show the evidence of this cosmic recycling. New nebulae would glow with the light of recently formed stars, their colors painting the darkness in shades of red, blue, and gold. Some of these stellar nurseries would be the direct descendants of the massive stars that died during your sleep, their heavy elements now incorporated into new worlds that might someday harbor life. Even stars with longer lifespans would show measurable changes. White dwarf stars, the hot, dense cores left behind when sun-like stars die, would have cooled significantly during your million-year rest. These stellar remnants begin their afterlives at temperatures exceeding 100,000 degrees, but they cool slowly over billions of years. The white dwarfs that existed before your sleep would have grown dimmer and redder, their surfaces cooling by thousands of degrees as they radiate their stored heat into the cosmic void. The sun itself, that steady beacon that has warmed Earth for billions of years, would continue its slow but inexorable evolution. Our star increases its brightness by about 1% every 110 million years as it gradually converts more of its hydrogen fuel into helium. Over the course of your million-year sleep, this change would be imperceptible, but it represents part of the sun's long journey toward its own eventual transformation into a red giant, billions of years in the future. The planets in our solar system would continue their ancient orbital dance, but even these seemingly stable motions would show subtle changes over such vast timescales. The gravitational interactions between planets create tiny perturbations in their orbits, effects that accumulate over millions of years. Mercury's orbit would have shifted slightly, its perihelion advancing by tiny amounts due to relativistic effects and gravitational influences from other planets. The asteroid belt between Mars and Jupiter would have evolved as well, with countless small collisions and gravitational nudges slowly reshaping the distribution of rocky debris left over from the solar system's formation. Perhaps most remarkably, the very positions of the stars themselves would have shifted during your sleep. Each star in our galaxy follows its own path through space, moving under the gravitational influence of the Milky Way's spiral arms and central black hole. These stellar motions, called proper motions, are usually so slow that they're imperceptible over human lifetimes. But 1 million years is long enough for these movements to become clearly visible. The constellations that have guided human navigation and imagination for thousands of years would have begun to change their shapes. The Big Dipper would look noticeably different, its stars having moved along their individual trajectories through the galaxy. Some bright stars would have shifted their positions in the sky by degrees, while others might have moved so far that they're no longer visible from the same vantage point. This stellar motion, reflects the larger dance of our galaxy itself. The Milky Way rotates like a vast pinwheel, with stars in the outer regions taking longer to complete their orbits around the galactic center than those closer in. Our Sun, located about halfway between the galactic center and edge, takes roughly 225 million years to complete one galactic year. During your million-year sleep, the solar system would have traveled only a tiny fraction of this orbit, but even this small motion would carry you to a subtly different neighborhood within the galaxy. The spiral arms of the Milky Way, those bright regions where new stars are born, would have shifted their patterns slightly during your rest. These arms are not fixed structures, but rather density waves that move through the galaxy like ripples on a cosmic pond. As these waves pass through different regions, they compress the gas and dust, triggering bursts of star formation that light up the spiral arms with the blue glow of young, massive stars. Stars. During your deep slumber, these galactic spiral arms would continue their slow migration through space. And if one were to pass through our region of the galaxy, it would trigger a period of intense star formation nearby. New clusters of brilliant blue stars would ignite like cosmic flowers blooming in a vast garden, their light painting the surrounding gas clouds in brilliant shades of red and gold. These stellar nurseries would represent the universe's endless cycle of creation, destruction, and renewal, playing out on timescales that dwarf human comprehension. The space between stars, far from being empty, would also show subtle changes during your extended rest. Vast clouds of hydrogen gas, some stretching across hundreds of light years, would slowly drift and evolve under the gentle pressure of stellar winds and the shock waves from distant supernovae. These molecular clouds, the raw material from which new stars are born, would gradually change their shapes and densities, like slow-motion sculptures carved by invisible cosmic forces. Some of these gas clouds might encounter the gravitational influence of passing stars, or the pressure waves from stellar explosions, causing them to begin the slow collapse that leads to star formation. Over the course of your million-year sleep, you might witness the birth of entirely new stellar systems, their planets forming from the leftover disk of dust and gas that swirls around each newborn star. The cosmic radiation environment around you would tell its own story of deep time. High-energy particles, accelerated by the magnetic fields of rotating neutron stars called pulsars, would continue their billion-year journeys across the galaxy. Some of these cosmic rays might have been created by supernova explosions that occurred during your sleep, their energetic particles now spreading outward at nearly the speed of light, carrying news of stellar death to distant corners of the galaxy. The magnetic field of our galaxy itself would have evolved subtly during your rest. This vast magnetic structure, generated by the motion of charged particles in the galactic disk, helps to shape the paths of cosmic rays and influences the formation of new stars. Like a slow river changing its course over geological time, the galactic magnetic field would have shifted its patterns slightly, creating new pathways for energy and matter to flow through the cosmos. As your sleep continues, the gravitational dance of nearby stars would create a constantly changing stellar neighborhood. Stars that were once distant might have approached our region of the galaxy, while others that were close neighbors might have drifted away on their own orbital paths around the galactic center. This stellar motion is so gradual that it would be imperceptible on human timescales, but over a million years, it would create a noticeably different arrangement of nearby stars. Some stars in our local neighborhood might have evolved into red giants during your sleep, swelling to enormous sizes as they near the end of their main sequence lifetimes. These aging stars would have grown so large that if they were placed where our sun sits, their outer layers might extend past the orbit of Mars. Their surfaces, cooled by this expansion, would glow with a deep red light, creating new beacons in the night sky that weren't there when you began your slumber. The deaths of nearby stars would have created beautiful planetary nebulae, those cosmic butterflies formed when dying stars gently expel their outer layers into space. These glowing shells of gas, illuminated by the hot white dwarf cores left behind, would have expanded during your sleep, growing larger and fainter as they slowly dispersed their material back into the interstellar medium. Each planetary nebula represents a star's final gift to the galaxy, enriching the space between stars with the heavy elements forged in stellar cores over billions of years. The very space around you would also show evidence of dark matter's invisible influence. This mysterious substance, which makes up about 27% of the universe, continues to gather in vast filaments and clumps under the patient pull of gravity. During your million-year rest, dark matter would have continued its slow accumulation, creating an ever more complex web of invisible structure that guides the formation of galaxies and the large-scale architecture of the cosmos. Ordinary matter, the atoms that make up stars, planets, and everything we can see, follows the gravitational scaffolding created by dark matter. During your sleep, gas and dust would have continued to flow along these invisible highways, sometimes accumulating in dense nodes, where new galaxies might eventually form, other times spreading into the vast voids that separate galactic clusters. The expansion of space itself, driven by the enigmatic force called dark energy, would have continued its relentless acceleration during your rest. This expansion is so gentle that it only becomes noticeable over truly cosmic distances, but it represents one of the most profound mysteries in modern cosmology. Dark energy, which comprises about 68% of the universe, appears to be pushing space itself apart at an ever-increasing rate. During your million-year sleep, this cosmic expansion would have carried the most distant galaxies slightly further away from your position. The light from these remote systems would have become a tiny bit more redshifted, stretched to longer wavelengths by the expansion of space through which it travels. This redshift is like a cosmic Doppler effect, telling us that the universe continues to grow larger and more dilute as time passes. The cosmic microwave background radiation, that faint echo of the Big Bang that fills all of space, would have cooled by an imperceptible amount during your rest. This ancient light, which has been cooling and redshifting for nearly 14 billion years, would continue its slow fade as the universe expands around it. The change over a mere million years would be so small that it would require incredibly sensitive instruments to detect, but it represents the universe's continued journey away from the hot, dense state in which it began. As you sleep, suspended in the cosmic dark, the very atoms in your body would have their own story to tell about deep time. The carbon in your cells was forged in the nuclear furnaces of ancient stars that died billions of years ago. The iron in your blood was created in the heart of a massive star that exploded as a supernova, scattering its heavy elements into the cosmos. The calcium in your bones was synthesized in stellar cores and dispersed by stellar winds over millions of years. These elements, the building blocks of life itself, represent the universe's long history of stellar death and rebirth. During your million-year sleep, new generations of stars would have continued this cosmic alchemy, creating fresh supplies of heavy elements and distributing them throughout the galaxy. The universe would have become slightly more enriched in the elements necessary for rocky planets and complex chemistry, slowly increasing the potential for new worlds to develop the conditions necessary for life. The gravitational waves created by distant cosmic events would have continued to ripple through space-time during your sleep, carrying information about some of the most violent processes in the universe. The collision of two black holes, occurring perhaps thousands of light years away, would send waves through the fabric of space itself, stretching and compressing distances by amounts smaller than the width of an atomic nucleus. These waves would pass through your sleeping form at the speed of light, barely disturbing your rest, but carrying news of cosmic catastrophes across the galaxy. Neutron stars, those incredibly dense remnants of massive stellar explosions, would have continued their rapid rotation during your sleep, some spinning hundreds of times per second like cosmic lighthouses. As these stellar remnants gradually lose energy, their rotation slowly decreases over millions of years. The pulsars that existed before your sleep would have aged noticeably, their pulse periods slightly longer than when you first closed your eyes. The magnetic fields of these neutron stars, trillions of times stronger than Earth's magnetic field, would have evolved during your rest as well. These intense magnetic fields accelerate particles to incredible energies, creating beams of radiation that sweep across space like lighthouse beams. The gradual decay of these magnetic fields over millions of years would have dimmed some pulsars, while potentially creating new types of neutron stars with different emission characteristics. During your extended slumber, the Milky Way's central black hole, that gravitational monster with a mass of about 4 million suns, would have continued its patient consumption of nearby material. Gas and dust falling into this cosmic abyss would have created brief flares of X-ray emission as the matter heated to millions of degrees before crossing the event horizon and disappearing forever. These feeding events would have illuminated the galactic center intermittently, like a slow-motion strobe light powered by gravity itself. The orbits of stars near the galactic center would have evolved during your sleep as well. Some stars, following highly elliptical paths around the central black hole, complete their orbits in just a few decades or centuries. During your million-year rest, these stars would have completed thousands of orbits, their paths slowly precessing under the influence of general relativity, like cosmic examples of Einstein's predictions about the nature of space-time. The space between galaxies, those vast empty regions that contain almost no visible matter, would have shown their own subtle evolution during your sleep. Dark matter continues to accumulate in these voids, creating an invisible web of gravitational influence that will eventually guide the formation of new cosmic structures. The expansion of space would have made these intergalactic distances slightly larger, pushing neighboring galaxies a tiny bit further apart. Distant galaxy clusters, those massive collections of hundreds or thousands of galaxies bound together by gravity, would have continued their slow gravitational dance during your rest. The individual galaxies within these clusters follow complex orbits around the cluster's center of mass, sometimes colliding and merging over hundreds of millions of years. During your million-year sleep, the positions of galaxies within nearby clusters would have shifted slightly, like a slow-motion ballet performed on scales almost too vast to comprehend. The cosmic web itself, that magnificent large-scale structure of the universe composed of dark matter filaments connecting galaxy clusters, would have evolved during your sleep. New filaments might have formed as dark matter continued to accumulate under gravity's influence, while others might have grown thicker as more matter flowed along their invisible highways. This cosmic scaffolding guides the flow of ordinary matter throughout the universe, creating the framework upon which all visible structures are built. As your million-year sleep draws toward its end, the accumulated changes in your cosmic neighborhood would have created a subtly different universe from the one you left behind. The night sky would show new stars and missing old ones, shifted constellations, and evolved stellar colors. The space between stars would contain new elements forged in stellar cores. New planetary nebulae expanded from dying stars, and new molecular clouds beginning their slow collapse toward future star formation. The magnetic field patterns of the galaxy would have shifted, creating new paths for cosmic rays and charged particles. The gravitational influence of dark matter would have continued shaping the large-scale structure of the universe, building the invisible architecture that guides the formation of all cosmic structures we can see. When you finally begin to stir from your impossible sleep, the universe around you would be both familiar and changed. The fundamental laws of physics would remain exactly the same. Gravity would still curve space-time. Light would still travel at its universal speed limit. and the electromagnetic force would still bind atoms together. But the consequences of these unchanging laws, played out over the vast canvas of 1,000,000 years, would have painted a cosmos subtly different from the one you left behind. The gentle expansion of space, the patient evolution of stars, the slow dance of galaxies, and the invisible accumulation of dark matter would have continued their eternal rhythms while you rested. In this way, your 1,000,000-year sleep would reveal one of the most profound truths about our universe: that it is simultaneously permanent and ever-changing, governed by eternal laws but never static, always evolving on timescales that stretch far beyond the brief flicker of any individual consciousness. As you slowly open your eyes to this transformed cosmos, you would be witnessing the universe's own patient way of marking time, not with the ticking of clocks or the turning of calendar pages, but with the birth and death of stars, the drift of galaxies, and the slow, majestic unfolding of cosmic evolution itself. The first thing you would notice upon awakening would be the profound silence. Space, of course, has always been silent, but after 1,000,000 years of cosmic evolution, even the patterns of electromagnetic radiation around you would have shifted into new frequencies, new rhythms. The radio waves from distant pulsars would have changed their timing slightly, like cosmic metronomes that have gradually slowed their beat. Some pulsars that were spinning rapidly when you began your sleep would have lost energy through their magnetic braking, their lighthouse beams now sweeping more slowly across the galaxy. The cosmic background hum of radio waves, that faint electromagnetic whisper left over from stellar processes throughout the galaxy, would carry new signatures. Supernova remnants that exploded during your sleep would still be expanding outward, their shockwaves heating the thin gas between stars and creating new sources of radio emission. These expanding bubbles of hot gas, some now hundreds of light years across, would have carved cavities in the interstellar medium, creating vast hollow spaces where once there was only the gentle density of cosmic dust and hydrogen. The very chemistry of space would have evolved during your rest. The interstellar medium, that thin soup of atoms and molecules that fills the space between stars, would be measurably enriched with heavy elements. Each supernova that exploded during your 1,000,000-year sleep would have contributed tons of iron, nickel, and other metals to this cosmic broth. Over time, these elements would have mixed and dispersed, carried by stellar winds and supernova shockwaves across distances measured in hundreds of light years. This gradual enrichment of space means that any new stars forming in your cosmic neighborhood would have access to more heavy elements than their predecessors. These younger stars might develop planetary systems with more rocky worlds, more asteroids rich in metals, and perhaps more of the complex chemistry that could someday give rise to life. The universe would have become slightly more hospitable to the formation of Earth-like worlds during your extended slumber. The magnetic field lines that thread through interstellar space would have evolved as well, twisted and shaped by the rotation of the galaxy and the explosive forces of dying stars. These magnetic fields, though incredibly weak by earthly standards, play a crucial role in guiding the formation of new stars and shaping the paths of charged particles throughout the galaxy. During your sleep, stellar winds and supernova explosions would have reconnected these field lines in new configurations, creating fresh pathways for cosmic rays and charged particles to follow. Some of the molecular clouds in your vicinity, those vast stellar nurseries where new suns are born, might have begun the slow process of gravitational collapse during your 1,000,000-year rest. These clouds, often spanning dozens of light years, collapse so gradually that even 1,000,000 years represents only the early stages of star formation. You might awaken to find dense cores beginning to form within nearby clouds, the first tentative steps toward the birth of new stellar systems that won't fully ignite for millions of years yet to come. The gravitational influence of these collapsing clouds would have subtle but measurable effects on their surroundings. As matter falls inward under its own gravity, it would slightly alter the gravitational field in the region, potentially deflecting the paths of comets in the outer reaches of nearby star systems. These tiny perturbations accumulate over vast timescales, eventually reshaping the architecture of planetary systems in ways that would only become apparent after millions of years of patient observation. Your own solar system would show clear evidence of this deep time passage as well. The asteroid belt, that rubble-strewn region between Mars and Jupiter, would have evolved through countless small collisions and gravitational interactions. Some asteroids would have been nudged into new orbits, while others might have been shattered by impacts, creating fresh debris fields. The largest asteroids, like Ceres and Vesta, would show new crater patterns from impacts that occurred during your sleep, their surfaces recording the slow bombardment history of the inner solar system. The Kuiper Belt, that distant realm of icy objects beyond Neptune, would have undergone its own subtle transformations. Objects in this region follow highly elliptical orbits that take centuries or millennia to complete. During your million-year sleep, each Kuiper Belt object would have completed hundreds or thousands of orbits, their paths slowly evolving under the gravitational influence of the giant planets. Some objects that were once in stable orbits might have been perturbed into new trajectories, while others might have been captured into orbital resonances with Neptune. Even more distant, in the Oort cloud, that vast spherical shell of comets surrounding our solar system at distances measured in light years, the patient gravitational influence of passing stars would have reshaped the distribution of icy bodies. Stars that wandered close to our solar system during your sleep would have gravitationally stirred this distant reservoir of comets, potentially sending showers of these icy visitors toward the inner planets. Some comets that began their inward journey during your slumber might just be approaching the sun for the first time as you awaken, their pristine surfaces beginning to sublimate in the solar heat. The planets themselves would have continued their intricate gravitational dance, but with subtle changes accumulated over deep time. Jupiter's great red spot, that massive storm larger than Earth that has raged for centuries, might have evolved significantly or even dissipated entirely during your rest. The gas giant's atmospheric dynamics operate on timescales ranging from days to centuries, and 1,000,000 years would have allowed for countless cycles of storm formation, evolution, and decay. Saturn's magnificent ring system would show clear signs of evolution as well. The countless ice particles that make up these rings are constantly colliding, merging, and breaking apart in an endless cycle of destruction and renewal. Over 1,000,000 years, the ring system would have lost some of its mass to Saturn's atmosphere, while potentially gaining new material from the disruption of small moons or captured comets. The intricate spokes and braided structures visible in the rings today would have been replaced by entirely new patterns, sculpted by electromagnetic forces and gravitational resonances. The moons of the outer planets would have their own stories of change to tell. Io, Jupiter's volcanically active moon, would have resurfaced itself multiple times during your sleep, its sulfur-spewing volcanoes constantly painting new landscapes across its tortured surface. Europa's icy crust might have shifted and cracked in new patterns, potentially exposing fresh areas of the subsurface ocean to space, or creating new pathways for water to reach the surface. Titan, Saturn's largest moon with its thick atmosphere and methane lakes, would have experienced countless seasonal cycles during your rest. This distant world's weather patterns operate on timescales of Saturn's 30-year orbital period, meaning your 1,000,000-year sleep would have encompassed over 30,000 Titanian seasons. The methane lakes would have evaporated and reformed countless times, carving new river channels and depositing fresh layers of organic compounds across the moon's surface. Even Mars, that rusty world that has captured human imagination for centuries, would show measurable changes after such an extended period. The planet's thin atmosphere continues to leak slowly into space, stripped away by solar wind and cosmic radiation. Over 1,000,000 years, this atmospheric loss would be clearly detectable, making Mars even thinner and colder than it was when you began your sleep. The planet's polar ice caps would have gone through countless cycles of growth and retreat, potentially exposing new layers of ancient Martian rock or revealing fossils from the planet's warmer, wetter past. The very orbit of Mars itself would have evolved slightly during your slumber. This planet's orbit is more elliptical and variable than Earth's, influenced by gravitational perturbations from Jupiter and the other planets. Over geological timescales, Mars experiences dramatic changes in its axial tilt and orbital eccentricity that profoundly affect its climate. While 1,000,000 years might not be enough to see the most extreme of these changes, the planet's orbital parameters would have shifted measurably, potentially altering the seasonal patterns and the distribution of ice across the Martian surface. Earth's own moon would have drifted slightly further away during your sleep, continuing its gradual recession from our planet. The moon moves away from Earth at about 3.8 centimeters per year due to tidal forces, meaning that over 1,000,000 years, it would have receded by about 38 kilometers. This might seem like a small change, but it would have subtle effects on Earth's rotation and tidal patterns. Days would be slightly longer and the tides slightly weaker, as the gravitational dance between Earth and Moon continues its ancient rhythm. The gravitational effects of this lunar recession would have accumulated over your 1,000,000-year sleep, creating measurable changes in Earth's rotational dynamics. The planet's rotation would have slowed slightly, adding perhaps a few seconds to the length of each day. This change would be imperceptible to human senses, but it represents the ongoing evolution of the Earth-Moon system as tidal forces gradually transfer angular momentum from Earth's rotation to the Moon's orbital motion. The space between Earth and Moon would have been crossed by countless meteors and space debris during your sleep, some of which might have created new craters on the lunar surface. The Moon's lack of atmosphere means that every impact, no matter how small, leaves a permanent scar on its surface. Over 1,000,000 years, thousands of new craters would have appeared, ranging from tiny pits created by micrometeorites to larger scars from asteroid impacts. The lunar surface you would observe upon awakening would be subtly different, marked by the accumulated history of cosmic bombardment. Even the Sun itself would have evolved during your extended rest, though its changes would be almost imperceptibly gradual. Our star has been slowly brightening throughout its lifetime, as the nuclear fusion in its core gradually changes the composition of its interior. The helium ash produced by hydrogen fusion makes the core slightly denser, causing it to contract and heat up, which in turn increases the rate of fusion reactions. This process causes the Sun's luminosity to increase by about 1% every 110 million years. Over your 1,000,000-year sleep, this solar evolution would have increased the Sun's brightness by less than 0.001%, a change so small it would be virtually undetectable. However, this represents part of the Sun's inexorable journey toward its eventual transformation into a red giant, billions of years in the future. The solar wind, that stream of charged particles flowing constantly outward from the Sun, might have shown subtle variations in intensity and composition as the star's magnetic field evolved through countless 11-year solar cycles. The heliosphere, that vast bubble of space dominated by the solar wind, would have maintained roughly the same size and shape during your sleep, but its detailed structure would have evolved. The boundary where the solar wind meets the interstellar medium, called the heliopause, fluctuates slightly as our solar system moves through regions of varying interstellar density. During your 1,000,000-year journey, the solar system would have traveled about 220 billion kilometers through space, potentially encountering regions where the local interstellar medium is slightly denser or more rarefied. These variations in the local cosmic environment could have subtle effects on the heliosphere's structure and on the amount of cosmic radiation reaching the inner solar system. The magnetic field lines carried by the solar wind would have been twisted into new configurations by the Sun's rotation and by interactions with the interstellar magnetic field. These changes would be too subtle to affect planetary climate significantly, but they would represent the ongoing interaction between our solar system and the galaxy that contains it. The zodiacal light, that faint glow visible in dark skies just after sunset or before dawn, would tell its own story of deep time evolution. This light is sunlight scattered by countless tiny dust particles in the inner solar system, debris from comets and asteroids that has accumulated over billions of years. During your million-year sleep, this dust cloud would have been constantly replenished by new impacts and comet passages, while simultaneously being swept up by planetary atmospheres and blown away by solar radiation pressure. The overall amount and distribution of this interplanetary dust would have evolved during your rest, creating subtle changes in the intensity and color of the zodiacal light. New comet passages would have contributed fresh dust particles, while the Poynting-Robertson effect would have caused existing particles to spiral slowly inward toward the Sun. The dust cloud you would observe upon awakening would be composed of entirely different particles than the one you left behind, though its overall appearance would remain familiar. The cosmic ray environment throughout the solar system would have fluctuated during your sleep as well. These high-energy particles, accelerated by distant supernovae and other cosmic phenomena, constantly bombard our solar system from all directions. The intensity of cosmic rays varies with the solar cycle, decreasing when the Sun's magnetic field is strongest and increasing during solar minimum periods. Over your million-year slumber, the solar system would have experienced roughly 90,000 solar cycles, each lasting about 11 years on average. During solar maximum periods, the enhanced solar magnetic field would have provided better shielding from cosmic rays, while solar minimum periods would have allowed more of these energetic particles to penetrate the inner solar system. The cumulative effects of this cosmic ray bombardment would have been recorded in the surfaces of airless bodies like asteroids and the Moon, creating subtle changes in their mineral composition through nuclear reactions. The very atoms in the meteorites and cosmic dust surrounding you would bear witness to these cosmic ray interactions. Cosmogenic isotopes, created when cosmic rays strike atomic nuclei, would have accumulated in exposed surfaces throughout the solar system during your sleep. These radioactive isotopes serve as cosmic clocks, recording the exposure history of objects to the interplanetary radiation environment. As you begin to stir from your impossible million-year sleep, the accumulated changes in your immediate cosmic neighborhood would paint a picture of patient, inexorable evolution. The space around you would be subtly different in its magnetic field configuration, its dust content, its chemical composition, and its population of small bodies. The gravitational architecture of the solar system would have evolved through countless small perturbations, creating new orbital relationships and altering the long-term stability of various celestial objects. The asteroid families, groups of objects created by ancient collisions, would have continued to evolve through the Yarkovsky effect, where absorbed sunlight creates tiny thrust forces that gradually alter orbital parameters. Some asteroids that belong to well-defined families when you began your sleep might have drifted far enough from their siblings to be considered independent objects. New collision events during your slumber might have created fresh asteroid families, their members slowly dispersing along similar orbital paths. The very concept of awakening from such a sleep raises profound questions about consciousness and the nature of time itself. Your brain, somehow preserved in perfect stasis for a million years, would contain memories and neural patterns from a cosmic epoch that has passed into deep history. The electromagnetic patterns of thought that defined your consciousness would need to somehow bridge that vast temporal gap, reconnecting with a universe that has moved on without you. The photons of light that were traveling through space when you first closed your eyes would now be 1,000,000 light years away, carrying information about the cosmic state at the moment your sleep began. New photons, emitted by stars that were born, lived and died during your slumber, would now be illuminating your awakening consciousness. In a very real sense, you would be opening your eyes to entirely new light, electromagnetic radiation that has been created by stellar processes that occurred while you rested. The gravitational waves that were rippling through space-time when you began your sleep would also now be impossibly distant, having propagated across the galaxy at light speed. New gravitational waves, created by black hole mergers and neutron star collisions that occurred during your million-year rest, would be passing through your location as you awaken. These space-time distortions carry information about some of the most violent events in the universe, events that unfolded while you dreamed in the cosmic dark. Your awakening would occur in a universe where entropy has increased, where the overall disorder of cosmic systems has grown slightly larger. Stars have burned more of their nuclear fuel, converting ordered hydrogen into more complex nuclear products, and ultimately into the random motion of heat. The cosmic microwave background radiation has cooled by an imperceptible amount as the universe has expanded, spreading its energy over an ever larger volume of space. Yet despite all these changes, the fundamental constants that govern physical reality would remain exactly the same. The speed of light, the strength of gravity, the charge of an electron, and all the other parameters that define how matter and energy interact would be precisely identical to what they were when you began your sleep. The universe operates according to laws that transcend time, even as their consequences play out in an endless symphony of change and evolution. The mathematical relationships that describe orbital mechanics, stellar evolution, and cosmic expansion would be unchanged, but they would have had 1,000,000 years to work their patient magic on the matter and energy around you. Every force, every field, every quantum interaction would have continued according to the same physical principles, but their cumulative effects would have reshaped the cosmos in subtle and profound ways. As you slowly return to consciousness in this transformed yet familiar universe, you would be experiencing one of the most remarkable perspective shifts imaginable. Your personal timeline, compressed into a single moment of awakening, would suddenly rejoin the cosmic timeline that has been flowing steadily onward for 1,000,000 years. You would be like a time traveler, but one who has moved forward through time at the universe's own patient pace, allowing natural processes to unfold around your sleeping form. The stars that would greet your awakening eyes would be the same nuclear furnaces that were burning when you began your sleep, but they would be 1,000,000 years older, their fuel supplies slightly more depleted, their evolutionary states subtly advanced. Some stars that were approaching the end of their main sequence lifetime when you closed your eyes might have begun their transformation into red giants while you slept, their surfaces now cooler and redder, their outer layers beginning the slow expansion that will eventually engulf their inner planets. The galaxy that contains you would have completed a tiny fraction of its 225 million-year rotation, carrying your sleeping form along an orbital path around the galactic center. The spiral arms would have shifted slightly, their density waves continuing their slow migration through the stellar disk. The supermassive black hole at the galaxy's heart would have accreted a small amount of additional matter, growing imperceptibly more massive as cosmic debris fell past its event horizon. In the vast web of dark matter that provides the invisible scaffolding for all cosmic structure, your 1,000,000-year sleep would represent just a moment in the ongoing construction project that has been building galactic clusters and superclusters for billions of years. The dark matter particles, whatever their nature, would have continued their gravitational dance, slowly accumulating in dense nodes and stretching into ever longer filaments that connect the bright islands of galaxies across cosmic voids. Your awakening would occur in a universe that is simultaneously ancient beyond human comprehension, and yet still young compared to its ultimate fate. The cosmos you would observe upon opening your eyes would still have trillions of years of stellar evolution ahead of it, eons during which the current generation of stars will die and be replaced by new ones, multiple times over. The universe would still be expanding, still cooling, still evolving according to the patient rhythms of cosmic time. The profound gift of such an awakening would be the perspective it provides on the nature of change itself. Your 1,000,000-year sleep would have allowed you to witness, in the space between one moment and the next, the universe's own way of marking time, not with the frantic ticking of mechanical clocks or the digital precision of atomic timekeepers, but with the slow, majestic unfolding of stellar evolution, planetary motion, and cosmic expansion. You would awaken to find that while everything has changed, nothing fundamental has changed. The same physical laws that governed the universe when you fell asleep would still be in effect. The same forces that shaped matter and energy would still be at work. The same mathematical relationships that describe how gravity bends space-time and how electromagnetic fields propagate through the vacuum would still hold true. This continuity within change, this permanence within flux, represents one of the deepest truths about the cosmos. The universe is simultaneously stable and dynamic, governed by eternal laws yet never static, always growing and evolving, and becoming something new while remaining fundamentally itself. Your million-year sleep would have allowed you to experience this paradox directly, to feel in your bones the way that time flows differently at different scales. The human experience of time, measured in heartbeats and seasons, and the span of individual lives, represents just one rhythm in the vast symphony of cosmic time. Stars have their own rhythms, measured in millions and billions of years. Galaxies dance to even slower music, their spiral arms rotating, and their central black holes growing over timescales that dwarf stellar evolution. The universe itself expands and cools according to a rhythm set by the Big Bang, a cosmic heartbeat that has been slowing for nearly 14 billion years. Your awakening from a million-year sleep would place you at the intersection of all these different temporal rhythms. Your consciousness, preserved somehow across deep time, would bridge the gap between human time and cosmic time, allowing you to experience directly how the universe evolves when observed from a perspective that transcends the brief flicker of individual existence. In the end, perhaps the most profound realization would be that the universe has continued its patient work of creation and destruction, growth and evolution, without any need for conscious observation or appreciation. The stars have burned their nuclear fuel, the planets have traced their orbital paths, and the galaxy has rotated through space, not because anyone was watching or caring, but simply because that is the nature of existence itself. The universe unfolds according to its own inner logic, its own deep patterns and rhythms, completely independent of any individual consciousness that might arise within it to contemplate its mysteries. Your million-year sleep would have demonstrated this cosmic autonomy in the most direct way possible, showing that the universe is perfectly capable of continuing its evolution, whether you are awake to witness it or not. Yet paradoxically, your awakening would also demonstrate the remarkable fact that the universe has somehow given rise to consciousness itself, to minds capable of contemplating cosmic evolution and appreciating the deep patterns that govern physical reality. Your preserved awareness, returning to activity after such a vast span of time, would represent the universe becoming conscious of itself once again, matter organizing itself into patterns complex enough to comprehend the very forces that shaped its existence. This awakening would be both humbling and magnificent, showing simultaneously how insignificant any individual consciousness is compared to cosmic evolution, and yet how remarkable it is that such consciousness exists at all. You would be a tiny spark of awareness in a vast universe, but a spark that carries within itself the capacity to understand and appreciate the cosmic processes that created it. As you slowly open your eyes to this transformed yet eternal cosmos, you would be participating in one of the universe's most profound achievements, the emergence of matter capable of contemplating its own existence, of consciousness capable of appreciating the deep beauty and mathematical elegance of the physical laws that govern all of existence. Your million-year sleep would end not with disappointment at how little has changed, nor with overwhelm at how much has changed, but with wonder at the patient, magnificent way the universe continues its ancient dance of creation, destruction, and renewal, whether anyone is watching or not. In this gentle awakening, you would find yourself once again part of the cosmic story, a conscious participant in the ongoing evolution of matter and energy and space-time itself. The universe would welcome you back, not with fanfare or drama, but with the same quiet constancy it has always shown. The same patient unfolding of physical law and mathematical relationship that has been creating beauty and complexity and wonder for nearly 14 billion years, and will continue to do so for trillions of years yet to come. Your sleep would be over, but the cosmic dream would continue, as it always has, as it always will, in the vast and gentle rhythm of universal time. The gentle stirring of consciousness after such an impossible sleep would bring with it a profound awareness of Earth itself, that blue marble that has been your species' home for hundreds of thousands of years. From your distant vantage point in space, Earth would appear much as it did when you first closed your eyes, a brilliant blue and white sphere suspended in the cosmic dark. But this familiar appearance would mask changes so profound that the world you once knew would have been transformed beyond recognition. The continents themselves would have shifted during your slumber, carried along by the patient movement of tectonic plates. The Atlantic Ocean would have grown wider by several dozen meters as the seafloor spreading centers continued their work, pushing Europe and North America further apart at the stately pace of a few centimeters per year. Africa would have crept northward, closing the Mediterranean Sea by a measurable amount and continuing its slow collision with Europe that builds the Alps grain by grain, earthquake by earthquake. The Himalayas would have grown taller during your sleep as the Indian subcontinent continued its relentless push into Asia. These mighty peaks, already the tallest on Earth, would have gained perhaps 100 meters in height as the collision zone between these massive pieces of Earth's crust continued to buckle and fold. The process happened so slowly that no human lifetime could witness it, but 1,000,000 years provides enough time for mountains to rise like slow-motion waves frozen in stone and ice. The Pacific Ring of Fire would have continued its restless activity, with countless volcanic eruptions reshaping island chains and coastal regions. New volcanic islands might have emerged from the ocean depths while others disappeared beneath the waves. The Hawaiian island chain would have drifted further northwest on its tectonic plate, while new volcanic islands began forming over the hotspot that has been creating these Pacific paradises for millions of years. The great ice sheets would have advanced and retreated multiple times during your sleep, following the patient rhythm of orbital cycles that govern Earth's long-term climate. Milankovitch cycles, those subtle variations in Earth's orbit and rotation that occur over tens of thousands of years, would have carried the planet through perhaps 40 complete cycles of glacial and interglacial periods. Each ice age would have locked up vast amounts of water in continental ice sheets, lowering sea levels and exposing land bridges between continents. Each interglacial period would have melted these ice sheets, raising sea levels and flooding coastal plains. The coastlines you might have known before your sleep would have been redrawn countless times by these rising and falling seas. During glacial periods, you could have walked from Alaska to Siberia across the exposed Bering Land Bridge. Britain would have been connected to continental Europe by dry land. The shallow seas between Southeast Asian islands would have drained away, creating continuous landmasses where now there are scattered archipelagos. During interglacial periods, these same regions would have flooded again, creating new seas and isolating populations on islands that were once connected by land. Florida would have been reduced to a small peninsula, or perhaps a chain of islands during the warmest periods, while vast areas of what is now the shallow North Sea would have been submerged beneath hundreds of feet of water. The atmosphere itself would have cycled through these climate changes, its composition fluctuating with the growth and decay of ice sheets, forests, and grasslands. During glacial periods, atmospheric carbon dioxide levels would have dropped as cold oceans absorbed more of this greenhouse gas, and as reduced plant growth removed less carbon from the air. During interglacial periods, warming oceans would have released carbon dioxide back into the atmosphere, while expanding forests and grasslands increase the rate of photosynthesis. These atmospheric changes would have been subtle by human standards, but significant enough to help drive the climate cycles that reshaped the planet's surface again and again. The oxygen content of the atmosphere would have fluctuated as well, rising and falling with changes in ocean circulation and the burial of organic matter in sediments. These variations would have been small, but over 1 million years, they would have accumulated into measurable shifts in the chemical composition of the air. The magnetic field that protects Earth from cosmic radiation would have undergone perhaps 1 or 2 complete reversals during your sleep. These geomagnetic reversals occur roughly every few 100,000 years on average, when the planet's magnetic field weakens, becomes chaotic for a few thousand years, and then re-establishes itself with the magnetic poles reversed. During these transition periods, Earth's protection from cosmic rays would have been temporarily reduced, allowing more high-energy particles to reach the upper atmosphere. The aurora displays during these reversal periods would have been spectacular and chaotic, visible much closer to the equator than normal, as the weakened and disorganized magnetic field allowed charged particles from the solar wind to penetrate deeper into the atmosphere. The magnetic field reversals would have left their signature in the volcanic rocks that formed during your sleep, creating a complex pattern of magnetic orientations that geologists could read like pages in Earth's history book. The very length of Earth's day would have changed during your million-year slumber, growing gradually longer as tidal forces from the moon continued to slow the planet's rotation. Each day would have gained perhaps a few seconds over the entire span of your sleep, an almost imperceptible change that nonetheless represents the ongoing evolution of the Earth-Moon system. This rotational slowing would have been accompanied by the Moon's continued recession, as the gravitational interaction between Earth and Moon gradually transfers energy from Earth's spin to the Moon's orbital motion. The precession of Earth's axis would have completed roughly 40 full cycles during your sleep, each cycle lasting about 26,000 years. This slow wobble of Earth's rotational axis changes which stars appear at the celestial poles and alters the timing of the seasons relative to Earth's orbital position. The North Star that guided navigation when you began your sleep would have been replaced by other stars as the axis of rotation slowly traced its circular path among the constellations. The planet's climate would have responded to these precessional cycles, with the timing of ice ages influenced by how the wobbling axis affects the distribution of sunlight across Earth's surface throughout the year. When the axis tilts to bring northern summers closer to the sun, ice sheets tend to retreat. When northern summers occur when Earth is farther from the sun, ice sheets tend to advance, locking up water and lowering sea levels. The biosphere would have evolved dramatically during your absence, with countless species extinctions and the emergence of entirely new forms of life. Evolution operates continuously, and 1 million years provides ample time for significant biological change. Many of the species you might have known before your sleep would have either evolved into new forms or disappeared entirely, replaced by organisms better adapted to changing environmental conditions. The ongoing Holocene extinction, driven by human activity and climate change, might have continued for some time after you began your sleep, removing many large mammals and countless smaller species from Earth's ecosystems. But life is remarkably resilient, and the empty ecological niches left by extinct species would eventually have been filled by new organisms evolving to exploit available resources. Ocean ecosystems would have been particularly dynamic, responding to the repeated changes in sea level, temperature, and chemistry that accompanied the glacial cycles. During glacial periods, lower sea levels would have eliminated many shallow marine habitats, while creating new ones as continental shelves were exposed to air and then re-flooded. Deep ocean circulation patterns would have shifted with changes in global temperature gradients, altering the distribution of nutrients and affecting the entire marine food web. Coral reefs would have been repeatedly stressed by sea level changes and temperature fluctuations, with many reef systems dying during unfavorable periods, and new ones establishing during more hospitable times. The species composition of these reefs would have evolved continuously, with new corals, fish, and other marine organisms appearing while others vanished. The Great Barrier Reef, the Amazon rainforest, and other iconic ecosystems would have been transformed multiple times, their boundaries shifting and their species composition evolving with the changing climate. Forests would have migrated across continents following the advancing and retreating ice sheets, with boreal forests moving south during glacial periods and tropical forests expanding during interglacial warming. These massive vegetation changes would have left their mark in pollen records, preserved in lake sediments and peat bogs, creating a detailed history of how plant communities responded to climate change over geological time. The Amazon rainforest might have been reduced to isolated refugia during the driest periods, only to expand again when moisture returned. The Sahara Desert would have oscillated between its current arid state and periods when it supported grasslands and even forests, as orbital cycles shifted the position of tropical rainbelts. These vegetation changes would have profoundly affected global carbon cycles, with forests absorbing carbon dioxide during expansion periods and releasing it when they contracted or burned. Mountain ranges would have served as refugia for cold-adapted species during warm periods and as barriers to migration during climate transitions. The Rocky Mountains, the Andes, and the Himalayas would have been biological islands where species could survive climate changes that eliminated them from surrounding lowlands. These mountains would also have continued their slow growth during your sleep, gaining height through continued tectonic activity, while simultaneously being worn down by erosion and glaciation. The great rivers of the world would have carved new channels during your absence, their courses shifting with changes in climate and sea level. The Mississippi River would have built new deltas and abandoned old ones as ice sheets advanced and retreated, changing the river's flow and sediment load. The Nile would have responded to changes in African climate, sometimes flowing strongly when the monsoons intensified and sometimes reduced to a trickle during arid periods.
Wow.
These river systems would have transported enormous quantities of sediment from the continents to the oceans, building new deltas and filling in coastal basins. The sedimentary record deposited during your million-year sleep would preserve a detailed history of climate change, volcanic eruptions, and biological evolution, layer upon layer of Earth's autobiography written in mud and sand. Volcanic activity would have continued throughout your slumber, with major eruptions periodically affecting global climate by injecting ash and sulfur compounds into the stratosphere. Yellowstone's supervolcano might have erupted during your sleep, covering much of North America with ash and temporarily cooling global temperatures. The volcanic islands of Hawaii would have continued their slow migration northwest, while new islands formed over the underlying hotspot. The Cascades, the Andes, and other volcanic mountain ranges would have experienced countless eruptions, building new peaks while older ones were eroded away. These volcanic regions would have been constantly reshaped by the interplay between tectonic forces that build mountains and erosional processes that wear them down. Some volcanoes that existed when you began your sleep would have been completely eroded away, while entirely new volcanic systems would have emerged from the Earth's restless interior. Lakes and inland seas would have appeared and disappeared with changes in climate and drainage patterns. During glacial periods, many regions that are now dry would have supported large freshwater lakes as changed precipitation patterns and blocked drainage created temporary basins. The Great Salt Lake, the Caspian Sea, and other large inland water bodies would have fluctuated dramatically in size, sometimes expanding far beyond their current boundaries, and sometimes shrinking to mere remnants. These changing water bodies would have supported their own evolving ecosystems, with fish and other aquatic organisms adapting to fluctuating salinity and water levels. Some lakes would have become completely isolated during dry periods, leading to the evolution of endemic species found nowhere else on Earth. When the lakes later expanded or connected to other water bodies, these unique species might have spread to new habitats or been driven to extinction by competition with immigrants. The polar ice sheets would have been perhaps the most dynamic feature of the changing Earth during your sleep. The Antarctic ice sheet would have advanced and retreated with global climate cycles, at times extending far out onto the continental shelf, and at other times retreating inland. The Arctic ice sheet would have grown and shrunk even more dramatically, at times extending across much of northern North America and Eurasia, and at other times disappearing almost entirely. These ice sheet fluctuations would have had profound effects on global sea level, ocean circulation, and weather patterns. When ice sheets were at their maximum extent, so much water would have been locked up as ice that sea levels dropped by more than 100 meters, exposing vast areas of continental shelf and creating land bridges between continents. When the ice sheets melted during interglacial periods, the released water would have flooded these exposed areas and drowned coastal forests and grasslands. The weight of these massive ice sheets would have depressed the underlying land, causing the continents to slowly sink under the ice load. When the ice later melted, the land would have gradually rebounded, rising like a slow-motion balloon as the weight was removed. This glacial isostatic adjustment would still have been continuing during your awakening, with some regions still rising thousands of years after the ice disappeared. The aurora borealis and aurora australis would have painted the polar skies throughout your sleep, their patterns changing with the solar cycle and with variations in Earth's magnetic field. During magnetic field reversals, these light shows would have been visible much closer to the equator, creating spectacular displays in regions that normally never see the aurora. The interaction between the solar wind and Earth's magnetic field would have continued its ancient dance, creating these beautiful reminders of the electromagnetic forces that shape our local corner of the solar system. Earth's geological activity would have left a complex record in the rocks formed during your million-year absence. New layers of sediment would have accumulated in ocean basins and lake beds, preserving fossils of the organisms that lived and died during this time. Volcanic eruptions would have created new rock formations while weathering and erosion removed others. Mountain building would have folded and fractured the Earth's crust in some regions, while others remained stable and quiet. The slow but relentless process of plate tectonics would have continued to recycle Earth's crust, with new oceanic crust forming at mid-ocean ridges, while older crust was subducted back into the mantle at deep ocean trenches. This crustal recycling would have gradually changed the chemical composition of the oceans and atmosphere as different types of rock were weathered and different volcanic compositions were erupted. Mineral deposits would have formed during your sleep as hydrothermal activity concentrated valuable elements in ore bodies. Hot springs and geysers would have deposited layers of silica and carbonate minerals, while underground water systems concentrated metals and other valuable materials. Some mineral deposits that existed when you began your sleep would have been eroded away and dispersed, while entirely new deposits would have formed in response to changing geological conditions. The deep Earth would have continued its slow convection during your absence, with hot material rising from the core mantle boundary and cooler material sinking back down. This convective motion drives plate tectonics and generates Earth's magnetic field, processes that would have continued their ancient rhythm throughout your million-year sleep. The core itself would have cooled slightly, releasing heat that powers the geodynamo and maintains the protective magnetic field. Meteorite impacts would have continued to bombard Earth during your sleep, with countless small impacts creating tiny craters and perhaps one or more large impacts creating significant geological features. These cosmic impacts would have delivered small amounts of extraterrestrial material to Earth's surface, while occasionally causing temporary climate disturbances through dust injection into the atmosphere. The accumulated effect of these impacts over 1 million years would have been to add a thin layer of cosmic dust to Earth's surface and to create numerous small craters, most of which would have been quickly erased by erosion. The Earth's energy budget would have remained in approximate balance during your sleep, with incoming solar radiation roughly matching outgoing thermal radiation. But this balance would have fluctuated with orbital cycles and solar variability, creating the climate changes that drove ice ages and shaped the evolution of life. The planet's albedo would have changed with ice sheet growth and retreat, vegetation changes, and cloud cover variations, creating feedback loops that amplified or moderated climate changes. As you slowly return to consciousness and begin to perceive this transformed yet familiar world, you would be witnessing the results of countless natural processes operating over timescales far longer than human experience typically encompasses. The Earth would be recognizably the same planet you left behind, but every detail would have been touched by the patient hand of geological time. Mountains would have grown and eroded, coastlines would have shifted, and life itself would have continued its endless dance of adaptation and evolution. The atmosphere you would breathe upon awakening would be composed of oxygen and nitrogen molecules that had been cycled countless times through living organisms during your sleep. The water in the oceans would have evaporated and condensed millions of times, falling as rain and snow, flowing in rivers, and returning to the sea in an endless hydrological cycle. Even the rocks beneath your feet would have been slowly altered by chemical weathering, their minerals gradually dissolved and transported to the oceans where they would eventually be incorporated into new sedimentary layers. This constant recycling of matter would have continued throughout your sleep, driven by energy from the sun and from Earth's interior. Nothing would have remained static, yet everything would have remained recognizably terrestrial. The fundamental character of Earth as a water-rich, geologically active, biologically vibrant world would have persisted even as countless details changed and evolved. The magnetic field that protected Earth during your sleep would still be there upon your awakening, though perhaps reversed in polarity and certainly shifted in its detailed structure. The Van Allen radiation belts would still encircle the planet, trapping charged particles from space and protecting the surface from harmful radiation. The ozone layer would still filter ultraviolet light from the sun, though its thickness and distribution might have changed with variations in atmospheric chemistry and solar output. Earth's rotation would still create the Coriolis effect that drives weather patterns and ocean currents, though the planet's spin would have slowed slightly, and the patterns themselves would have evolved with changing continental configurations and ice sheet distributions. The seasons would still follow their annual cycle, though the timing relative to Earth's orbital position would have shifted due to axial precession. The moon would still rise and set in Earth's sky, though from a slightly greater distance and appearing slightly smaller than when you began your sleep. The tides would still ebb and flow under lunar influence, though perhaps with different timing and amplitude due to changes in ocean basin shape and Earth's rotation rate. The gentle gravitational dance between Earth and Moon would have continued its ancient rhythm, slowly transferring energy and angular momentum in a process that has been ongoing for billions of years. The sun would still warm Earth's surface each day, though the star itself would have aged slightly during your sleep, burning a tiny fraction more of its hydrogen fuel and growing imperceptibly brighter. The solar wind would still stream outward from the sun, interacting with Earth's magnetic field to create the auroras and maintain the heliosphere that protects the inner solar system from some galactic cosmic rays. As you contemplate this transformed Earth from your impossible vantage point in space, you would be seeing the result of countless cycles of change and renewal, destruction and creation, all playing out according to the same physical laws that governed the planet when you first closed your eyes. The processes that shaped the world during your sleep would still be operating, still slowly molding the planet's surface, atmosphere and biosphere in an endless dance of geological and biological evolution. The Earth you would observe upon awakening would be a testament to the power of gradual change accumulating over vast timescales. Mountains built grain by grain, canyons carved drop by drop, species evolved generation by generation, all adding up to transformations so complete that virtually nothing would remain exactly as it was, yet so gradual that the fundamental character of the planet would persist unchanged. This paradox of constant change within apparent stability would extend far beyond Earth to encompass the entire solar system and galaxy. The same patient processes that reshaped your home planet would have been operating throughout the cosmos, creating new stars and destroying old ones, building planets and grinding them to dust, always changing, yet always following the same eternal laws of physics. The asteroid belt would have continued its slow evolution during your sleep, with countless small collisions, gradually altering the distribution of rocky debris left over from the solar system's formation. Some asteroids would have been perturbed into new orbits by gravitational encounters with Jupiter or Mars, while others would have been shattered by impacts, creating fresh clouds of smaller fragments. The largest asteroids like Ceres and Vesta would have accumulated new crater patterns from impacts that occurred during your slumber, their surfaces recording the ongoing bombardment history of the inner solar system. New asteroid families would have formed from collision events during your million-year rest, their members slowly spreading along similar orbital paths as gravitational perturbations and the subtle Yarkovsky effect gradually altered their trajectories. Some asteroid families that existed when you began your sleep would have dispersed so much that their common origin would no longer be apparent, while others would have remained tightly clustered, still clearly related by their similar orbits and compositions. The Kuiper belt beyond Neptune would have shown its own evolution, with countless icy objects following their elliptical orbits around the Sun. Some of these trans-Neptunian objects would have been perturbed by gravitational encounters into new trajectories, while others would have maintained their stable orbits for the entire duration of your sleep. The largest objects like Pluto and Eris would have completed hundreds of orbits during your absence, their surfaces slowly evolving under the influence of sublimation and cosmic ray bombardment. Comets from the distant Oort cloud would have continued their occasional journeys into the inner solar system, some perhaps making their first appearance since you began your sleep. These icy visitors would have brought fresh supplies of water and organic compounds from the outer reaches of the solar system, occasionally colliding with planets or moons and delivering their cosmic cargo to worlds that might otherwise remain dry and barren. The moons of the giant planets would have undergone their own subtle transformations during your million-year absence. Europa's icy crust would have been repeatedly fractured and reformed by tidal forces from Jupiter, perhaps exposing fresh areas of the subsurface ocean to space, or creating new pathways for potential life to reach the surface. Enceladus would have continued its dramatic geysering activity, spewing water and organic compounds from its south polar region into space, some of which would have been captured by Saturn to replenish the planet's E-ring. Titan's thick atmosphere would have continued its complex chemistry throughout your sleep, with methane and nitrogen combining to form increasingly complex organic compounds that rain down onto the moon's surface. The methane lakes and rivers of this distant world would have evaporated and reformed countless times, carving new channels and depositing fresh layers of organic sediments across the landscape. This moon might have developed an even richer inventory of prebiotic chemistry during your absence, making it an even more intriguing target for the search for life. The magnetospheres of the giant planets would have continued their complex interactions with the solar wind throughout your sleep, trapping charged particles and creating radiation belts around each world. Jupiter's powerful magnetic field would have continued to accelerate particles to extreme energies, making the radiation environment around this planet even more hazardous for any spacecraft that might venture too close. The auroras of Jupiter, Saturn, Uranus, and Neptune would have danced continuously in their polar regions, powered by the interaction between planetary magnetic fields and the flow of charged particles from the Sun. Even the Sun itself would have shown subtle signs of evolution during your million-year slumber. Our star would have converted approximately 4 billion tons of hydrogen into helium each second throughout your sleep, gradually altering the composition of its core and very slowly increasing its luminosity. The solar magnetic field would have undergone roughly 90,000 complete cycles during your absence, each cycle lasting about 11 years and bringing changes in solar activity that affected the entire heliosphere. Solar flares and coronal mass ejections would have continued to erupt from the sun's surface throughout your sleep, occasionally sending powerful bursts of charged particles streaming toward the planets. These solar storms would have interacted with planetary magnetospheres, creating enhanced aurora displays and occasionally disrupting the upper atmospheres of worlds like Earth and Mars. The cumulative effect of millions of these solar events would have been to gradually strip away small amounts of atmosphere from planets that lack strong magnetic protection. The heliosphere itself, that vast bubble of space dominated by the solar wind, would have maintained its basic structure throughout your sleep, while showing subtle variations as the solar system moved through regions of different interstellar density. The heliopause, where the solar wind meets the interstellar medium, would have fluctuated slightly in distance as our star system encountered denser or more rarefied regions of the local galactic environment. The very fabric of space around the solar system would have been continuously disturbed by gravitational waves passing through from distant cosmic events. Black hole mergers, neutron-star collisions, and other catastrophic events occurring throughout the galaxy would have sent ripples through space-time itself, stretching and compressing distances by amounts far smaller than the width of an atomic nucleus. These gravitational waves would have passed through your sleeping form and through all the planets and moons of the solar system, carrying information about some of the most violent processes in the universe. The cosmic ray environment throughout the solar system would have fluctuated with the solar cycle and with the passage of shock waves from distant supernova. During solar maximum periods, the enhanced solar magnetic field would have provided better shielding from galactic cosmic rays, while solar minimum periods would have allowed more of these high-energy particles to penetrate the inner solar system. The surfaces of airless bodies like the Moon and asteroids would have recorded this varying cosmic ray bombardment in the form of nuclear reactions that created cosmogenic isotopes. As your consciousness slowly returns, and you begin to perceive the solar system that has evolved around your sleeping form, you would be witnessing the results of countless small changes accumulating over deep time. Each planet would still follow its ancient orbital path, yet the detailed positions would be different. Each moon would still circle its parent planet, yet their surfaces would show the accumulated effects of 1 million years of impacts, volcanism, and other geological processes. The asteroid belt would still occupy the space between Mars and Jupiter, yet its detailed structure would have evolved through countless collisions and gravitational perturbations. The Kuiper belt would still extend beyond Neptune, yet the populations of icy objects would have been reshuffled by the patient influence of planetary gravity and stellar encounters. Even the Oort cloud, that distant reservoir of comets at the very edge of the solar system, would have been stirred by the gravitational effects of passing stars. The interplanetary medium itself would have evolved during your sleep, with the solar wind carrying away small amounts of material from planetary atmospheres, while occasionally bringing fresh supplies of cosmic dust and meteoritic debris from interstellar space. The zodiacal light visible in dark skies would tell the story of this evolution, its intensity and color subtly changed by the accumulation of new dust particles and the removal of old ones. The magnetic field lines threading through interplanetary space would have been constantly twisted and reconnected by the solar wind and by interactions with planetary magnetospheres. These invisible field lines guide the flow of charged particles throughout the solar system, creating a complex electromagnetic environment that influences everything from comet tail formation to planetary aurora displays. The detailed configuration of this magnetic landscape would have evolved continuously during your sleep, though its basic structure would remain recognizably similar to what exists when you first closed your eyes. The gravitational influence of the planets would have continued their subtle dance throughout your sleep, creating small perturbations in each other's orbits that accumulate over vast timescales. Mars would have drifted slightly in its orbital parameters, its path around the Sun showing measurable changes from the cumulative effects of gravitational interactions with Jupiter and the other planets. These orbital shifts would be tiny by human standards, but significant enough to be detected by precise measurements comparing the planet's position before and after your million-year rest. Venus, that brilliant morning and evening star, would have maintained its nearly circular orbit while showing subtle changes in its rotational state. This planet's incredibly slow rotation, which takes longer than its orbital period, would have evolved slightly due to atmospheric tides and gravitational interactions with Earth and the Sun. The thick carbon dioxide atmosphere would have continued its super greenhouse effect, maintaining surface temperatures hot enough to melt lead, while the planet's volcanic activity continued to reshape its hidden surface. Mercury, the innermost planet, would have completed millions of orbits around the Sun during your sleep, its elliptical path showing the cumulative effects of relativistic precession and gravitational perturbations from the other planets. This small world would have continued its extreme temperature cycles, with the day side reaching temperatures above 400 degrees Celsius, while the night side plunged to minus 170 degrees. The planet's thin atmosphere would have been constantly stripped away by the solar wind and replenished by outgassing from the surface. The gas giants beyond the asteroid belt would have shown their own subtle evolution during your million-year absence. Jupiter's Great Red Spot, that massive anticyclonic storm that has raged for centuries, might have evolved significantly in size and intensity, or perhaps dissipated entirely, only to be replaced by new atmospheric features. The planet's complex system of radiation belts would have continued trapping charged particles from the solar wind, while the 4 large Galilean moons maintained their gravitational dance, their orbits locked in resonant relationships that have persisted for billions of years. Saturn's magnificent ring system would have undergone continuous evolution throughout your sleep, with countless ice particles colliding, fragmenting, and reaggregating in an endless cycle of destruction and renewal. The intricate spoke patterns and braided ring structures visible today would have been replaced by entirely new configurations, sculpted by electromagnetic forces and gravitational resonances with the planet's many moons. Some ring material would have spiraled inward to be consumed by Saturn's atmosphere, while new material might have been added from the disruption of small moons or captured comets. The shepherding moons that maintain the sharp edges of Saturn's rings would have continued their gravitational gardening throughout your sleep, their orbital motions creating waves and gaps in the ring system, while preventing the rings from spreading outward into a diffuse disk. These small moons themselves would have evolved through countless impacts with ring particles and meteoroids, their surfaces gradually accumulating a dark lag deposit of organic compounds and rocky debris. Uranus and Neptune, those distant ice giants, would have completed dozens of their lengthy orbits during your sleep, each planet taking decades to circle the Sun once. Uranus would have continued its unique tumbling motion, rotating on its side relative to its orbital plane in a configuration that creates extreme seasonal variations lasting decades at each pole. Neptune's dynamic atmosphere would have continued generating the fastest winds in the solar system, with storm systems appearing and disappearing in patterns that reflect the planet's internal heat source. The many moons of these outer planets would have their own stories of evolution to tell. Miranda, Uranus's small moon, with its bizarre patchwork terrain, would have continued its slow geological evolution under the influence of tidal heating and impact cratering. Triton, Neptune's large retrograde moon, would have continued its gradual spiral inward due to tidal forces, bringing this captured Kuiper Belt object ever closer to its eventual destruction and transformation into a ring system around Neptune. Throughout the outer solar system, the countless small bodies that make up the Kuiper Belt and scattered disk would have continued their slow gravitational evolution. These remnants from the solar system's formation follow highly elliptical orbits that take centuries or millennia to complete, meaning that during your million-year sleep, each object would have traveled its orbital path hundreds or thousands of times. The gravitational influence of the giant planets would have gradually modified these orbits, sending some objects into the inner solar system as comets while ejecting others into interstellar space. The heliosphere, that vast bubble of space dominated by the solar wind, would have maintained its basic structure throughout your sleep, while showing variations related to the solar cycle and changes in the local interstellar environment. As the solar system moved through its orbit around the galactic center, it would have encountered regions of varying interstellar density and magnetic field strength, causing subtle changes in the shape and size of the heliosphere. The termination shock, where the solar wind suddenly slows as it encounters the interstellar medium, would have fluctuated in distance from the Sun as these environmental changes affected the balance between solar wind pressure and interstellar pressure. The heliopause itself, that boundary where the solar wind gives way to the interstellar medium, would have shown similar variations, sometimes closer and sometimes more distant, as the solar system's motion carried it through different regions of local space. Beyond the heliosphere lies the true interstellar medium, that thin soup of gas and dust that fills the space between stars. During your million-year sleep, the solar system would have traveled through perhaps a dozen different interstellar clouds, each with its own density, temperature, and chemical composition. These clouds represent the remnants of ancient supernova explosions and the stellar winds from massive stars, gradually mixing and dispersing their contents throughout the galaxy. The passage through these interstellar clouds would have subtle effects on the solar system, temporarily increasing the density of material flowing past the heliosphere and potentially affecting the flux of cosmic rays reaching the inner planets. Some clouds might contain unusual isotopic ratios that reflect their origin in specific stellar explosions, while others might be enriched in heavy elements forged in the cores of massive stars. The local stellar neighborhood would have shown clear signs of evolution during your extended sleep. The nearest star to our Sun, Proxima Centauri, would have continued its slow orbit around the Alpha Centauri binary system, while showing the flare activity typical of red dwarf stars. This small, cool star might have produced thousands of powerful flares during your absence, each one temporarily brightening the star and sending bursts of X-ray and ultraviolet radiation toward any planets that might orbit in its vicinity. Barnard's star, another nearby red dwarf known for its high proper motion across the sky, would have moved a measurable distance during your sleep, its position shifting by several arc-seconds as it follows its path through the galaxy, Wolf 359, Leyland 2 1185, and the other stars within a few dozen light-years of the Sun would have shown similar proper motions, gradually changing the configuration of our local stellar neighborhood. Some of these nearby stars might have undergone significant evolutionary changes during your million-year rest. While most low-mass red dwarfs change very slowly, any intermediate-mass stars in the solar neighborhood might have evolved from main sequence stars into red giants or white dwarfs. These stellar transformations would have been accompanied by mass loss through stellar winds, potentially enriching the local interstellar medium with heavy elements and affecting the chemical composition of nearby molecular clouds. The Hyades and Pleiades star clusters, those bright groupings visible to the naked eye, would have continued their gradual dispersal as individual stars slowly escape the cluster's weak gravitational binding. Some stars that were cluster members when you began your sleep might have wandered far enough away to be considered field stars, while the remaining cluster members would have spread into looser configurations. Open star clusters throughout the galaxy would have shown similar evolution, with the youngest clusters remaining tightly bound, while older clusters gradually dissolved into the galactic disk. Some clusters would have encountered molecular clouds during their orbital motion around the galaxy, leading to renewed star formation and the creation of new stellar associations. Others would have been torn apart by encounters with massive objects or by the differential gravitational effects of the galactic disk. The globular clusters that orbit the Milky Way in a vast spherical halo would have maintained their basic structure throughout your sleep, these ancient stellar cities being held together by much stronger gravitational forces than open clusters. However, even these stable systems would have shown subtle evolution as stars in their dense cores occasionally collided and merged, creating unusual stellar objects like blue stragglers and X-ray binaries. The galactic disk itself would have continued its slow rotation during your absence, carrying the solar system along its orbital path around the galactic center. The Sun completes one galactic orbit roughly every 225 million years. So your million-year sleep would have carried you through only a small fraction of this cosmic year. However, even this small motion would have been enough to change your perspective on the galaxy's structure. The spiral arms that give the Milky Way its characteristic pinwheel appearance would have shifted slightly during your sleep, these density waves moving through the galactic disk like ripples on a cosmic pond. The solar system might have moved closer to or farther from the nearest spiral arm, potentially affecting the local star formation rate and the flux of cosmic rays from young, massive stars. The galactic center, dominated by the supermassive black hole Sagittarius A star, would have continued its sporadic feeding throughout your sleep. Occasionally, gas clouds or unlucky stars would have wandered too close to the event horizon, creating brief flares of X-ray and gamma-ray emission as matter heated to millions of degrees before disappearing forever beyond the point of no return. These feeding events would have illuminated the galactic center intermittently, like a cosmic lighthouse powered by gravity itself. The orbits of stars near the galactic center would have evolved during your sleep as well, their highly elliptical paths slowly precessing under the influence of general relativity. Some of these stars complete their orbits in just a few decades, meaning they would have completed thousands of cycles during your million-year rest, each orbit carrying them from the outer reaches of the central cluster to within a few light hours of the black hole itself. The magnetic field of the galaxy would have undergone its own subtle evolution during your absence, shaped by the motion of charged particles in the galactic disk and by the explosive forces of supernovae and stellar winds. This vast magnetic structure helps to confine cosmic rays within the galaxy while also influencing the formation of new stars by affecting the collapse of molecular clouds. Cosmic rays, those high-energy particles accelerated by supernova shockwaves and other violent processes, would have continued their billion-year journeys through the galaxy during your sleep. Some cosmic rays that were just beginning their odyssey when you closed your eyes would still be traveling through interstellar space, their energies gradually diminishing through interactions with the interstellar medium and magnetic fields. The cosmic ray flux at Earth would have varied throughout your sleep, as the solar system moved through different regions of the galaxy and as the solar magnetic field underwent its 11-year cycles. During solar maximum periods, the enhanced solar wind would have provided better shielding from galactic cosmic rays, while solar minimum periods would have allowed more of these energetic particles to reach the inner solar system. The local group of galaxies, that small cluster that includes the Milky Way, Andromeda, and about 50 smaller galaxies, would have continued its gravitational dance throughout your sleep. Andromeda, currently approaching the Milky Way at about 110 kilometers per second, would have drawn measurably closer during your million-year absence, though the collision between these two spiral galaxies is still billions of years in the future. The smaller galaxies in the local group would have continued their own orbital motions, with some potentially showing signs of tidal disruption as they pass close to the larger galaxies. The Magellanic Clouds, those irregular satellites of the Milky Way, would have completed several orbits during your sleep while continuing to lose gas and stars to tidal forces and ram pressure stripping. The dark matter halos that surround each galaxy would have continued their slow evolution during your absence, accreting additional material from the cosmic web, while gradually relaxing into more spherical configurations. These invisible structures, which contain most of the mass in each galaxy, play a crucial role in determining the orbital motions of visible matter and the overall evolution of galactic systems. The cosmic web itself, that vast network of dark matter filaments connecting galaxy clusters across billions of light years, would have continued its patient construction project throughout your sleep. New filaments might have formed as dark matter continued to collapse under its own gravity, while existing structures would have grown more massive as they accreted material from surrounding voids. The expansion of space itself would have continued throughout your sleep, driven by the mysterious dark energy that comprises about 68% of the universe's total energy density. This expansion would have carried distant galaxies slightly farther away, making them appear slightly redder and fainter due to the stretching of their light during its journey through expanding space. The cosmic microwave background radiation, that faint echo of the Big Bang that fills all of space, would have cooled by an imperceptible amount during your sleep as the universe continued its expansion. This ancient light, which has been cooling and redshifting for nearly 14 billion years, would show a temperature decrease measurable only with the most sensitive instruments, yet it represents the universe's continued journey away from its hot, dense beginning. Gravitational waves would have continued rippling through space-time throughout your sleep, carrying information about the most violent events in the cosmos. Black hole mergers occurring thousands of light years away would have sent waves through the fabric of space itself, stretching and compressing distances by amounts smaller than the width of a proton. These waves would have passed through your sleeping form and through every planet and star in the galaxy, traveling at the speed of light and carrying news of cosmic catastrophes across vast distances. Neutrinos, those ghostly particles that barely interact with matter, would have streamed through your body by the billions every second during your sleep, most of them continuing their journeys unchanged. These particles, produced in the cores of stars and in supernova explosions, carry information about nuclear processes occurring throughout the galaxy and beyond, though their extremely weak interactions make them nearly impossible to detect. The vacuum of space itself would have remained as empty as ever during your sleep, yet this apparent nothingness seethes with quantum activity. Virtual particles would have constantly appeared and disappeared in fleeting quantum fluctuations, borrowing energy from the vacuum for impossibly brief moments before annihilating and returning their energy to the void. These quantum processes, though far too subtle to observe directly, represent the underlying activity that fills even the emptiest regions of space. As your consciousness slowly returns after this impossible million-year journey, you would be awakening to a universe that is simultaneously familiar and transformed. The same physical laws that governed reality when you first closed your eyes would still be in effect, yet their consequences would have accumulated into countless subtle changes across every scale from subatomic to cosmic. The photons of light that reach your awakening eyes would carry information about stellar processes that occurred while you slept. Electromagnetic radiation created by fusion reactions in stellar cores, by the acceleration of charged particles in magnetic fields, and by the thermal glow of warm dust clouds floating in the space between stars. This light would tell the story of cosmic evolution played out over geological time, each wavelength encoding information about temperature, motion, and chemical composition. Your awakening would occur in a universe where entropy has increased, where the overall disorder of cosmic systems has grown slightly larger as energy has flowed from hot objects to cool ones, as organized structures have slowly decayed, and as the expansion of space has stretched wavelengths and diluted energy densities. Yet this increase in entropy would be so gradual that the universe would remain capable of complex organization, still able to form stars and planets, and perhaps even life. The fundamental constants that govern all physical interactions would remain exactly the same as when you began your sleep. The speed of light, the strength of gravity, the masses of elementary particles, and all the other parameters that define how matter and energy behave would be precisely unchanged. These constants represent the eternal foundation upon which all cosmic evolution rests, the unchanging mathematical relationships that allow a universe of perpetual change to exist. The awakening from such an extended sleep would bring with it a profound shift in perspective on the nature of time itself. Your personal timeline, compressed into what feels like a single moment, would suddenly rejoin the cosmic timeline that has been flowing steadily onward for 1,000,000 years. You would be like a traveler returning from a journey through deep time, carrying with you the memory of a universe that no longer exists, while opening your eyes to one that has been patiently evolving in your absence. The stars that greet your awakening would be the same nuclear furnaces that illuminated your last waking moments, yet they would be 1,000,000 years older, their fuel supplies slightly more depleted, their evolutionary states subtly advanced. The constellations would show measurable changes as individual stars have followed their independent paths through space, their proper motions accumulating over deep time into noticeable shifts in the familiar star patterns. Some bright stars that dominated the night sky when you began your sleep might have evolved into red giants, their surfaces now cool and ruddy as they swell to enormous sizes in the final stages of their main sequence lifetimes. Others might have completed their evolution entirely, leaving behind white dwarf remnants or perhaps neutron stars if they were massive enough to end their lives in supernova explosions. The space between stars would be subtly enriched with heavy elements dispersed by stellar winds and supernova explosions that occurred during your sleep. This gradual chemical evolution of the galaxy would have increased the metallicity of the interstellar medium, providing raw materials for the formation of rocky planets around any new stars that might be born in the coming eons. Molecular clouds, those stellar nurseries where new suns are born, would have drifted and evolved under the influence of stellar winds, supernova shockwaves, and gravitational interactions with passing stars. Some clouds that existed when you began your sleep might have collapsed to form new star clusters, while others might have been dispersed by the energetic outflows from newly formed massive stars. The magnetic field lines threading through interstellar space would have been twisted and reconnected countless times during your sleep, creating new pathways for cosmic rays and charged particles while erasing old field configurations. These invisible magnetic structures play a crucial role in star formation by helping to remove angular momentum from collapsing gas clouds and by channeling matter along field lines during the accretion process. The galactic halo, that vast spherical region surrounding the Milky Way's disk, would have continued its slow evolution during your absence. Ancient globular clusters would have completed hundreds of orbits around the galactic center while maintaining their basic structure through the strong gravitational binding of their hundreds of thousands of member stars. High-velocity stars, ejected from the galactic center by encounters with the supermassive black hole, would have continued their escape trajectories, some perhaps reaching the outer edges of the halo or even escaping the galaxy entirely. Dark matter, that invisible component that comprises most of the galaxy's mass, would have continued its gravitational dance throughout your sleep. These mysterious particles, whatever their nature, would have maintained the large-scale structure of the galactic halo, while showing subtle evolution as the galaxy accreted additional dark matter from surrounding cosmic filaments. The local bubble, that region of hot, low-density gas that surrounds the solar system, would have evolved during your sleep as new supernova explosions occurred in nearby star-forming regions. This bubble, carved out by ancient stellar explosions, provides a relatively clear pathway for observing distant objects, while also affecting the propagation of cosmic rays and the chemistry of the local interstellar medium. Nearby star-forming regions like the Orion Nebula would have continued their stellar nursery activities throughout your sleep, with new stars igniting as gas clouds collapsed under their own gravity, while older stars dispersed the remaining gas through stellar winds and radiation pressure. These regions represent the ongoing cycle of stellar birth and death that has been enriching the galaxy with heavy elements for billions of years. The zodiacal dust cloud that creates the faint glow visible in dark skies would tell its own story of solar system evolution during your sleep. This cloud of microscopic particles, debris from comets and asteroid collisions, would have been constantly replenished by new sources while being depleted by planetary sweeping and radiation pressure from the sun. The dust grains present at your awakening would be entirely different from those that existed when you began your sleep, though the overall structure and brightness of the zodiacal light would remain similar. Interplanetary dust particles would have continued their slow spiral inward toward the sun throughout your sleep, driven by the Poynting-Robertson effect as they absorb solar radiation and re-emit it in a slightly different direction. This process gradually removes angular momentum from the particles, causing them to migrate inward over timescales of thousands to millions of years. The dust environment at your awakening would represent a completely renewed population of particles compared to what existed at the beginning of your sleep. The solar wind itself would have maintained its basic structure throughout your absence, while showing variations related to the solar magnetic cycle and the star's slow evolution. This stream of charged particles flowing outward from the sun at speeds of several hundred kilometers per second would have continued to carve out the heliosphere while interacting with planetary magnetospheres and gradually stripping away atmospheric components from worlds that lack strong magnetic protection. Planetary atmospheres throughout the solar system would have shown subtle evolution during your million-year sleep. Mars would have continued losing its thin atmosphere to space, with the solar wind and cosmic ray bombardment gradually eroding the tenuous envelope of carbon dioxide and trace gases. Earth's atmosphere would have cycled through numerous ice age and interglacial configurations as orbital variations drove long-term climate changes. Venus would have maintained its crushing carbon dioxide atmosphere throughout your sleep, the dense blanket of greenhouse gases continuing to trap solar energy and maintain surface temperatures hot enough to melt lead. The planet's slow retrograde rotation would have evolved slightly due to atmospheric tides and gravitational interactions, though these changes would be almost imperceptibly small. The gas giants would have continued their complex atmospheric dynamics throughout your absence, with Jupiter's Great Red Spot potentially evolving significantly or being replaced by entirely new storm systems. Saturn's hexagonal polar vortex would have maintained its remarkable geometric structure, while the detailed flow patterns within it evolved in response to seasonal changes and internal dynamics. The ring systems of Saturn and the other giant planets would have undergone continuous evolution during your sleep, with countless particle collisions creating new structures, while gravitational resonances with orbiting moons maintained overall stability. Some ring material would have been lost to planetary atmospheres, while new material might have been added from the breakup of small moons or the capture of cometary debris. The many moons throughout the solar system would have their own stories of evolution to tell. Io's volcanic activity would have completely resurfaced the moon multiple times during your sleep, creating entirely new landscapes of sulfur compounds and silicate lavas. Europa's icy crust would have been fractured and reformed repeatedly by tidal forces, potentially creating new pathways for the subsurface ocean to interact with the surface environment. Titan's methane cycle would have operated continuously throughout your sleep, with countless seasonal variations driving the evaporation and condensation of hydrocarbon lakes, the formation and dissolution of clouds, and the deposition of organic sediments across the moon's surface. This complex chemistry might have produced an even richer inventory of prebiotic compounds during your absence. The asteroid belt would have continued its slow collisional evolution, with impacts between rocky bodies gradually grinding larger objects into smaller fragments, while gravitational perturbations slowly altered orbital distributions. some asteroids would have been nudged into planet-crossing orbits, potentially delivering water and organic compounds to the inner planets through impact events. The Kuiper Belt and Oort cloud would have maintained their basic structure while showing the effects of stellar encounters and planetary perturbations. Occasional close approaches by passing stars would have stirred the distant comet reservoirs, sending showers of icy visitors toward the inner solar system, where they would sublimate in the solar heat and create spectacular tail displays. As you contemplate this transformed yet eternal solar system, you would be witnessing the results of countless natural processes operating according to unchanging physical laws over timescales far longer than human experience typically encompasses. The gravitational dance of planets, the nuclear fusion powering stellar cores, the electromagnetic interactions shaping plasma flows, and the quantum processes governing atomic behavior would have continued their ancient rhythms throughout your sleep. The solar system would remain recognizably the same while being subtly different in countless details. The same planets would orbit the same star, yet their positions, orientations, and surface features would reflect 1,000,000 years of patient evolution. The same moons would circle their parent planets, yet their cratering patterns, atmospheric compositions, and geological activity would show the accumulated effects of deep time. The asteroid belt would still occupy the space between Mars and Jupiter, yet its population would have been reshuffled by collisions and gravitational perturbations. The Kuiper belt would still extend beyond Neptune, yet the detailed orbital distribution of icy objects would reflect the cumulative influence of planetary gravity and stellar encounters. Even the Sun itself would remain essentially unchanged while showing subtle signs of stellar evolution. The nuclear fusion reactions in its core would have converted a tiny fraction more hydrogen into helium, gradually altering the star's internal structure and very slowly increasing its luminosity. These changes would be far too small to affect planetary climates significantly, but they represent the star's inexorable journey toward its eventual transformation into a red giant billions of years in the future. The heliosphere would have maintained its basic bubble-like structure, while fluctuating slightly in response to solar cycle variations and changes in the local interstellar environment. The boundary where the solar wind meets the interstellar medium would have shifted inward and outward as the solar system moved through regions of varying density and magnetic field strength. Throughout this cosmic evolution, the fundamental forces that govern all interactions would have remained absolutely constant. Gravity would still curve space-time according to Einstein's equations. Electromagnetic fields would still propagate at the speed of light, and the strong and weak nuclear forces would still govern the behavior of atomic nuclei. These eternal laws provide the unchanging foundation for a universe of perpetual change. As your consciousness fully returns and you begin to process the profound implications of your million-year journey through time, you would be experiencing perhaps the most remarkable perspective shift imaginable. Your personal sense of duration, compressed into what feels like a single moment of awakening, would suddenly reconnect with the vast flow of cosmic time that has continued unabated in your absence. The photons entering your eyes would carry information about stellar processes that occurred while you slept, electromagnetic radiation created by fusion reactions, planetary thermal emissions, and the scattered light of distant galaxies. Each wavelength would encode a story of cosmic evolution, from the ultraviolet glow of young massive stars to the infrared warmth of dust clouds heated by stellar radiation. The gravitational waves passing through your awakening body would bring news of violent cosmic events that occurred during your sleep, black hole mergers and neutron star collisions that sent ripples through the fabric of spacetime itself. These portions would carry information encoded in gravitational field fluctuations too subtle for any instrument to detect, yet representing the universe's own way of recording the passage of deep time. The neutrino flux streaming through your newly awakened form would tell stories of stellar processes that unfolded while you rested. These ghostly particles, created in the nuclear furnaces of distant stars and in the heart of our own sun, would have been traveling for thousands of years to reach your location, carrying with them the signatures of fusion reactions that occurred in stellar cores long before you began to stir from your cosmic sleep. The cosmic microwave background radiation, that ancient afterglow of the Big Bang itself, would have cooled by perhaps a few millionths of a degree during your slumber. This change would be so infinitesimally small that it could only be detected by instruments of extraordinary sensitivity, yet it represents the universe's continued expansion and cooling as it journeys ever further from its hot, dense beginning nearly 14 billion years ago. The very atoms that compose your awakening consciousness would carry their own stories of cosmic time. The carbon in your neural networks was forged in the cores of massive stars that lived and died billions of years ago, scattered into space by stellar winds and supernova explosions, then incorporated into the molecular clouds that eventually gave birth to our solar system. The iron in your blood carries the signature of stellar nucleosynthesis, created in the final moments of a star's life when silicon burning briefly illuminated the cosmos before collapse. An explosion dispersed these heavy elements into the galaxy. During your million-year sleep, countless new generations of stars would have continued this cosmic alchemy, creating fresh supplies of carbon, oxygen, silicon, and iron in their nuclear furnaces. Some of these newly forged elements would still be locked away in stellar cores, while others would have been dispersed by stellar winds into the interstellar medium, gradually enriching the galaxy's inventory of heavy elements and increasing the universe's capacity for complex chemistry. The quantum vacuum that surrounds you would have maintained its ceaseless activity throughout your sleep, with virtual particles continuously appearing and disappearing in brief quantum fluctuations that borrow energy from the void before returning it, in accordance with Heisenberg's uncertainty principle. These processes, though far too subtle to observe directly, represent the underlying quantum activity that fills even the most perfect vacuum, a reminder that empty space is never truly empty, but seethes with possibilities. The magnetic field lines threading through local space would have been continuously twisted and reconnected by the solar wind and by interactions with the interstellar magnetic field. These invisible structures, though incredibly weak by terrestrial standards, play crucial roles in guiding the flow of charged particles throughout the galaxy and in shaping the process of star formation as molecular clouds collapse under their own gravity. Your awakening would occur in a universe where the fundamental forces have maintained their eternal dance. The electromagnetic force would still bind electrons to atomic nuclei with precisely the same strength it possessed when you began your sleep. The strong nuclear force would still hold protons and neutrons together in atomic nuclei, overcoming their electromagnetic repulsion at short distances. The weak nuclear force would still govern certain types of radioactive decay, and gravity would still curve space-time according to the elegant mathematics of general relativity. These forces, acting in concert according to unchanging laws, would have orchestrated every cosmic process that unfolded during your sleep. They would have guided the orbital mechanics that carried planets around their stars, powered the nuclear fusion that illuminated stellar cores, shaped the electromagnetic phenomena that create auroras and solar flares, and governed the quantum processes that determine how matter and energy interact at the most fundamental level. The speed of light would remain exactly 299,792,458 meters per second, just as it was when you closed your eyes. This cosmic speed limit would have continued to govern the propagation of all electromagnetic radiation, from radio waves to gamma rays, ensuring that information about distant events could travel no faster than this universal constant allows. The light reaching your eyes at the moment of awakening would have been emitted by stars and galaxies at various distances, some photons having travelled for millions or billions of years to reach you at this precise moment. Planck's constant would retain its exact value, continuing to set the scale for quantum phenomena throughout the universe. The fine structure constant which determines the strength of electromagnetic interactions would remain precisely unchanged. The gravitational constant would maintain its role in determining how strongly masses attract each other across cosmic distances. These fundamental parameters represent the unchanging foundation upon which all cosmic evolution rests. As you slowly process the implications of your impossible journey through deep time, you would begin to understand that you have witnessed something profound about the nature of existence itself. The universe operates according to principles that transcend individual consciousness, following mathematical laws that govern everything from the motion of subatomic particles to the expansion of space itself. Your million-year sleep would have demonstrated this cosmic autonomy in the most direct way possible, showing that the universe continues its patient work of creation and evolution, regardless of whether anyone is present to observe it. Yet your awakening would also represent something remarkable, the return of consciousness to a cosmos that has given rise to minds capable of contemplating their own existence. Your preserved awareness, somehow bridging the vast temporal gap between sleep and waking, would embody the universe's extraordinary capacity to organize matter into patterns complex enough to understand the very forces that shaped their creation. The silence that would greet your awakening would be profound, not merely the absence of sound that characterizes the vacuum of space, but a deeper quiet that speaks to the patient, unhurried way cosmic processes unfold. This silence would carry within it the accumulated wisdom of 1,000,000 years of stellar evolution, planetary motion, and galactic rotation, all proceeding according to their own internal rhythms without fanfare or announcement. The darkness between stars would seem somehow different, not because the void itself has changed, but because your perspective would now encompass the vast timescales over which cosmic processes operate. The space between galaxies, those enormous empty regions that dwarf even stellar distances, would represent not emptiness, but potential, vast reservoirs where future cosmic structures might slowly condense from the invisible scaffolding of dark matter. The temperature of deep space, hovering just a few degrees above absolute zero, would feel both familiar and strange. This cosmic cold, the background temperature left over from the Big Bang and slowly decreasing as the universe expands, would have cooled by an imperceptible fraction during your sleep. Yet this tiny change represents the universe's continued journey away from its hot beginning, a process that will continue for trillions of years until the last stars burn out and the cosmos grows truly cold. Your awakening consciousness would need to reconcile the subjective experience of instantaneous sleep with the objective reality of deep time passage. The memories preserved in your neural networks would come from a cosmic epoch that has passed into history, while your sensory experience would be of a universe that has aged and evolved without your participation. This temporal displacement would create a unique perspective on the relationship between consciousness and cosmic time. The gravitational field that holds you in space would be subtly different from what it was when you began your sleep, altered by the redistribution of matter throughout the galaxy as stars formed and died, as gas clouds condensed and dispersed, and as the slow dance of stellar orbits carried mass from one region to another. These changes would be far too small to detect without extremely precise instruments, but they represent the cumulative effect of countless cosmic processes operating over geological time. The cosmic ray environment would tell its own story of the 1,000,000 years that passed while you slept. High-energy particles accelerated by supernova shockwaves and pulsar magnetospheres would have continued their billion-year journeys through the galaxy, some arriving at your location for the first time, while others passed by on their way to distant corners of the cosmos. The flux and composition of these cosmic rays would reflect the stellar explosions and other violent events that occurred during your absence. Even the vacuum of space around you would bear the invisible signatures of cosmic evolution. Trace amounts of interstellar gas and dust would have different chemical compositions than they possessed 1,000,000 years ago, enriched by stellar winds and supernova explosions that dispersed heavy elements throughout the galaxy. These changes would be detectable only through careful spectroscopic analysis, but they represent the universe's ongoing project of chemical evolution. The neutrino background, those nearly massless particles that stream through the cosmos in vast numbers, would carry information about nuclear processes that occurred throughout the galaxy during your sleep. Supernovae that exploded during your absence would have contributed their own distinctive neutrino signatures to this cosmic background, though detecting and interpreting these signals would require technology far beyond our current capabilities. As you contemplate the profound implications of your awakening, you would realize that you have experienced something that touches the very heart of what it means to exist in a cosmos governed by natural law. Your consciousness, somehow preserved across the vast gulf of deep time, would represent a bridge between the human experience of duration and the cosmic experience of eternity. The stars that illuminate your return to awareness would be engaged in the same nuclear processes that powered them when you first closed your eyes. Yet each would have aged in its own way. Some would have grown slightly brighter as helium ash accumulated in their cores, while others would have dimmed as they exhausted their fuel supplies. A few massive stars might have begun the rapid evolutionary changes that lead to their explosive deaths, their surfaces cooling and reddening as they swell into supergiant configurations. The interplay between gravity and nuclear fusion that powers stellar cores would have continued its ancient balance throughout your sleep, with some stars maintaining stable energy production, while others experience the instabilities that mark the end of main sequence evolution. This stellar aging process represents one of the universe's most fundamental clocks, marking the passage of cosmic time through the gradual consumption of nuclear fuel. The galactic magnetic field would have evolved during your absence, shaped by the rotation of the galaxy and by the explosive forces of stellar death. These magnetic field lines, though incredibly weak, help to confine cosmic rays within the galaxy, while also playing a role in the process of star formation by removing angular momentum from collapsing molecular clouds. Molecular clouds themselves would have undergone their own slow evolution during your sleep, some collapsing to form new star clusters, while others were dispersed by the energetic outflows from newly formed massive stars. The chemical composition of these stellar nurseries would have been gradually enriched by the heavy elements dispersed by stellar winds and supernova explosions, increasing the potential for the formation of rocky planets around future generations of stars. The cosmic web of dark matter that provides the invisible scaffolding for all visible structure would have continued its patient construction work during your absence. New filaments of dark matter might have condensed from the expanding universe, while existing structures grew more massive as they accreted material from their surroundings. This dark matter framework guides the formation of galaxies and galaxy clusters, creating the large-scale architecture that shapes cosmic evolution. Your million-year sleep would have spanned countless cycles of cosmic processes operating on different timescales. Solar-type stars would have completed millions of rotations, while more massive stars might have undergone significant evolutionary changes. Planetary systems would have experienced thousands of orbital cycles, while slowly evolving through gravitational interactions and the gradual loss of atmospheric components to space. The expansion of the universe itself would have carried distant galaxies slightly farther away during your sleep, making them appear redder and fainter due to the Doppler effect of cosmic expansion. This recession represents the continuing legacy of the Big Bang, the ongoing stretching of space that has been occurring for nearly 14 billion years and will continue for trillions of years into the future. Dark energy, that mysterious component that comprises about 70% of the universe's total energy density, would have continued its work of accelerating cosmic expansion throughout your sleep. This enigmatic force, whose nature remains one of cosmology's greatest puzzles, represents the dominant factor shaping the universe's ultimate fate, gradually overcoming gravity on the largest scales and ensuring that the cosmos will continue expanding forever. The quantum mechanical processes that govern matter at the most fundamental level would have operated continuously during your sleep, with atomic nuclei occasionally undergoing radioactive decay, electrons transitioning between energy levels, and particles appearing and disappearing in quantum field fluctuations. These processes, though occurring on scales far smaller than atoms, ultimately drive all the chemical and nuclear reactions that power cosmic evolution. As you slowly return to full consciousness, you would be participating in one of the universe's most remarkable achievements, the emergence of matter organized into patterns complex enough to contemplate the cosmos that created them. Your awakening would represent not just the return of individual awareness, but the universe becoming conscious of itself once again after 1,000,000 years of unconscious evolution. The profound gift of such an awakening would be the perspective it provides on the true nature of time and change. Your subjective experience of instantaneous sleep would be contrasted with the objective reality of cosmic evolution, demonstrating how the same physical processes can create entirely different experiences of duration, depending on the observer's frame of reference. The universe that greets your awakening would be both ancient beyond human comprehension and yet still young compared to its ultimate lifespan. The cosmic processes you would observe would still have trillions of years ahead of them, eons during which the current generation of stars will exhaust their fuel and be replaced by new ones, multiple times over. The universe would still be expanding, still cooling, still evolving, according to the patient rhythms of cosmic time. Your awakening would occur in a cosmos where entropy has increased, where the overall disorder of physical systems has grown slightly larger as energy has flowed from hot objects to cool ones, and as organized structures have slowly decayed. Yet this increase in entropy would be so gradual that the universe would remain fully capable of creating new organization, still able to form stars and planets, and perhaps even new forms of life. And so, as this impossible journey through deep time comes to its gentle close, you would find yourself forever changed by the experience of witnessing 1,000,000 years pass in a single moment. The universe that welcomed you back would be both utterly familiar and subtly transformed, a testament to the patient way that cosmic processes unfold according to their own ancient rhythms, indifferent to human observation, yet somehow more beautiful for their independence. Your awakening would carry within it the profound understanding that time flows differently at different scales, that the universe marks its passage not with the frantic ticking of clocks, but with the slow dance of stars, the patient drift of galaxies, and the gentle expansion of space itself. In the end, your 1,000,000-year sleep would reveal the most comforting truth of all, that the cosmos continues its magnificent work of creation and renewal, whether we are here to witness it or not, spinning its endless story of light and shadow, birth and death, in the vast and gentle rhythm of universal time. And in that knowledge, there is peace.